So here was the first part of your discussion question. That this was just a pretty straightforward implementation of those editing steps that we talked about last time in class. We said, well, now I'm giving you 2 separate prospects, and we can think about those 6 editing steps and discuss how they would be applied in this particular case. So notice here, the first thing that you should notice is that I didn't give you these prospects in our typical prospect theory notation. I didn't do, parentheses, outcome, comma, probability, semicolon, outcome, comma, probability, and so on and so forth. Because even that notation assumes that you've already gone through at least one of these editing steps. Right? So I try to give you this in as neutral as a way as possible. Neutral of a way as possible. We say, all right, what do we want to do with this? What do we want to do? What does it make sense to do first here?
Coding.
Yeah, so it seems here, at least it seems like we can generally agree that if we were going to go through this in an intuitive sort of way, we'd probably do the coding first, because really, what are you going to do? Simplify something when you haven't even decided what the gains and losses look like? So we said this first coding step just involves turning what information we're actually given into something that we can represent on some spectrum of gains and losses. Okay. So for this first prospect here, now we'll use the notation. I said, you expect to lose $10. We can talk about why that might matter. Our first potential outcome is then that we get $64.99. How would we code that as a gain or a loss? Yeah, let's not round anything yet because that's a separate step. But so if your baseline, and this is the whole concept of a reference point, right? That if what you're saying is, well, I expect to lose $10, I've acclimated to that world in which I lose $10. It's not unreasonable then to think that your reference point is a situation in which you lose $10. What you seem to be saying, you seem to be getting a little stuck or a little caught up with the notation, but you're like, I know it has to do with $64.99, and I know it has to do with the 10, and I need to squish those together in some way that makes sense. But so if you're expecting to lose 10 and you actually get $64.99, you're actually $74.99 better off than your reference point, right?
Yeah.
Okay. And again, you don't have to think about it that way. We're just trying to say, what would be one reasonable thing that a person would do in this situation where we can illustrate the different steps. That you, of course, could argue, well, even if I expect to lose $10, it hasn't happened yet, so I'm not acclimating to that, I'm refusing to think about it. And you could make an argument, in a specific way that your reference point is still a world in which you get $0. Just explain what you're doing, because we don't know for sure how reference points are created. But if we do take it as, expectations are feeding into what we feel is our reference point, we would do something like that. And then we could do the same thing with all the other ones too, right? That if we expect to lose 10 and we get 115 instead, we're actually 125 better than our psychological neutral. So we would end up turning this into 125 with probability 0.2, 50 with probability 0.5, and 25 with probability 0.1, right? So let's do the same thing for the other one. We say, well, okay, we did the coding exercise for one of these. Let's do the coding exercise for the other one. So now, in the other prospect, our psychological neutral is that we expect to gain $20. Okay, so we're going to feel basically neutral if that $20 materializes. How would we then interpret actually getting $70? Where would that fall on our spectrum of gains and losses? Yeah, you could argue if I've acclimated to this world in which I get $20, I'm seeing getting 70 rather than 20 is a, unexpected or uninternalized gain of 50. Okay. And again, you could argue, you would want to explain it. You wouldn't want to just do something. You would want to explain, I don't believe that this person is taking that 20 into account. Therefore, I'm coding gains and losses against a reference point of getting $0. That's fine. Explain what you're doing, though, because there is some sort of coding exercise going on in your head. It just might not be the same for every person. But yeah, by that logic, we'd have a gain of 50 with probability 0.1. We'd have a gain of 60 with probability 0.6. And we would have a gain of 110 with probability 0.3. So one of our 6 steps out of the way. 5 to go, right? What do you want to do?
Can you differentiate this between with segregation? Because segregation, you perceive something's definitely going to happen, as far as I remember.
Yeah.
So it's the same thing here. You definitely are going to gain $20. So is there? I mean, at least you think you are.
You think you are. So
right, yeah.
I guess that's the important difference,
yeah. So
right?
could you explain the difference between those two things, between coding and segregation in that case?
So the coding is vis-a-vis what you've already internalized is your, I will feel neutral about this. I will be at my reference point if this happens. With the segregation, when you're segregating out that, for sure amount, and you can think about this if you go back and look at the way that the expected value of the prospect formula looks for irregular prospects. We're not necessarily, we're segregating out and saying, oh yeah, we get that for sure. But we're not necessarily internalizing that and saying, I'm getting that for sure, therefore I've incorporated that into my idea of neutral.
So it's no longer, so segregation.
Yeah, so it's a subtle difference there, but you can think about it in the segregation phase, we haven't necessarily acclimated to that thing we've gotten for sure. Mm-hmm. We've just taken it out to try to make that risky component easier to analyze. Okay.
So if we hadn't coded it like this, and for example, did, I guess, what you would consider the segregation part first, and had your -10 and your 20 on the outside, and then kept your probabilities and your outcomes the same, that's not the same as this, because the expected values would be different, right?
Yeah, you'd get a slightly different number, and you would have a somewhat different interpretation, right? Because if you're simply segregating that out, you're saying, all right, fine, I get this thing for sure, but I haven't acclimated to it yet. Mm-hmm. Whereas if you're making that part of your reference point, you've acclimated to that, right? And the reason why that matters is because our prospect theory value function, they're not straight lines, right? So the marginal benefit, marginal cost that we can calculate depends on where we feel on that value function we are. And the curve is much steeper when we're near our reference point than it is elsewhere. So our choice of reference point is going to affect how we're perceiving costs and benefits. That's kind of the whole point, right? And, like I said, I was just asking you to do something here that makes sense, to give yourself practice applying these different things to make sure you can, list off what they are, what they are, and so on. That's for the most part what I'm concerned with here, rather than the specific semantics of the question. But you seem to be understanding, oh, hey, here are these different things that people do. So for the most part, that's fine. Okay. What do you want to do next? If you were trying to compare these two outcomes, decide which of them is more appealing to you, would you leave them like this, or would you do, other of those steps that we talked about last time? What would you do next?
You could, before doing anything else, do a simplification of the 74, the rounding to 75, just so it's easier.
Yeah, so it's unlikely that we would actually do some sort of expected calculation with 74.99. We're like, look, guys, that's basically 75. I'll buy that. And what is the name of the,
Simplification.
yeah, so it's gonna fall under the heading of simplification, right? Hi, this is getting less ugly. Hopefully as we go further and further down this path, the whole point is that we're creating something that's easier to compare, right? And if we were making things look uglier for ourselves rather than less ugly, it would be harder to believe that these are steps or heuristics that people actually use to make their lives easier. Okay, next.
You could segregate out the lowest outcome from each of them, so the prospect 1 could become 25 plus, and then just reduce or deduct 25 from each of your outcomes. And it become like 50 with an additional 50 with 0.2 probability, an additional 100 with 0.2, and then an additional 25 with 0.2.
And this is where this last part here becomes important, right? That one of the things we talked about last time was that we aren't sure in what order people are going to perform these operations. That it seemed like there was a consensus, at least in this class, where we're like, well, it seems like there's a reason that we would do coding first. And then, if we're just going for some sort of like the low-hanging fruit, you're like, well, obviously that's ugly, let's fix him. But then once we got past that point, there's not necessarily agreement as to what you would do next. So we have one vote for, you could segregate out the guaranteed gain that you're going to get in each of these cases. Raise your hand if that's the next thing that you did. So some of you, more than I would have guessed, actually. But you see, we have about a half and half. A half and half vote, essentially. So we're saying, oh, wait, yeah, it's not going to be uniformly obvious what we want to do next. Do we have another suggestion for what we would do next? No. And if we're going to use the word cancellation, we say cancellation involves looking, across the different prospects and saying, do they have something in common? And if they have something in common, can I just ignore that and focus on the differences? Right? So the whole point of this exercise is to make sure that you're very clear on what those different steps entail, right? And to be able to ask yourself, to be able to list them off, right? So we have, I don't even know that I could do it, coding, combination, cancellation, segregation, simplification,
dominance,
detection of dominance. Woohoo! To be able to say, here are the 6 things I need to be thinking about, not necessarily in that order, but get to a point where you can start, looking out for them and saying, all right, what might I do here to make this decision easier? And here, is there anything to combine? I don't think I'm going to do life that easy, right? We said the combination was sort of a no-brainer, that if I get $50 with probability 0.1, and then as a separate outcome I get $50 with probability 0.3, just put those guys together. And we can say there's not really any of that to be done. Here, doesn't seem like there's anything specifically to cancel yet, right? That you could make some sort of backwards argument that you could turn this 50 with probability 0.5 into maybe a 50 with probability 0.1 and a 50 with probability 0.4. That's weird because it's kind of going backwards. And then cancel part of it with the 50 with probability 0.1 down here. I don't know that that makes things better, so it would be hard to argue that someone's actually doing that. So we can go through those steps and say, can we apply these? And it seems like, it's not surprising that a lot of you got to this segregation as that next step. Mm-hmm.
I argued that the 50 with a probability of 0.5 and 60 with a probability of 0.6 were close enough that if it was a difficult decision, some people might cancel them out as being close enough and kind of like, cancel.
What exactly would you cancel? I want to make sure that this is clear, because you can't cancel things within a prospect, you can only cancel things across prospects.
Right, so I meant the 50 with a probability of 0.5 in the first one, and then 60 with a probability of 0.6 in the second one.
So you're doing some sort of approximation heuristic and being like, look, they're about the same. I've got to do this in my head. You haven't even given me paper. You're telling me which one I want. If I am just forced within the next 60 seconds to choose the one that I want, we're going to be more willing to round and approximate and do whatever than we might if we had paper and time to think about it, right? So, and I think you're exactly right. There becomes some sort of judgment call, like how resource constrained from a cognitive standpoint are we? The more resource constrained we feel, the more willing we are most likely to be more inclusive, let's say, with our editing steps and just be like, close enough. That's probably a thing, right? And that would be why there's some judgment call. As long as you can say, like, this is what I would do for this step, like I know literally what it means, I would probably do this, slight variation thereof. As long as you're tying it back to these, somewhat commonly accepted heuristics, that's fine. It's not likely that people perfectly conform to those, just as people don't perfectly conform to expected utility theory either. So let's say we segregate. Said we can segregate out at 25 in the first one. We can just say, got a 25, and then we get what? 50 with probability 0.2, 100 with probability 0.2, 25 with probability 0.5. And I'll write it, but you'll notice in the paper when they have outcomes of 0, they don't specifically write it. They just leave that implicit. They just leave it to you to figure out that the probabilities don't add to 1, and therefore we have an outcome of 0 with some positive probability. We could do the same thing with the second one. With the second one, we're now getting $50 for sure. And we're getting an additional 0 with probability 0.1, an additional 10 with probability 0.6, and an additional 60 with probability 0.3. Did you leave the choices like this? I mean, sometimes you can't apply all the steps, right? You just want to think about, is there something obvious that I can do? It seems like once you do this segregation exercise, some of the other steps become more difficult, right? Because if you're going to say, well, I segregated, and now I want to think about cancellation, you'd ask yourself, well, can I really cancel? Because we might have something that now, within the parentheses looks the same in both of the cases. However, they weren't really the same because the amount guaranteed I'm getting that I segregated out is actually different, right? So you want to be careful and think about, the order that you're doing this in not only potentially affects what point you're going to get to at the end, but it also could affect how reasonable it is to even do any of the other steps, right? So we did coding. We said there wasn't anything to combine, wasn't anything to cancel. We did some segregation. We did some simplification right up front when we did this 74.99 to 75. Any other simplification? You said that you would, potentially simplify and be like 50 is easy, 60 is hard. Be more, lax in your simplification in that way. So we did some of that. Is there, when we talked about detection of dominance, I got a few questions about this because it's not as well defined as these other steps. And we showed, in one case, we could say that one prospect dominates another if we have the same probabilities in both prospects and then the values are just higher in one of them. That would be easy to compare. We could have, one prospect dominate another one if if the potential outcomes were the same, but one had a higher probability associated with the good outcome, then we could say one dominates the other. But the idea of dominance is that for any reasonable value function that a person could have, one of these options is always going to look better. And we can really only see that when we have things that we can compare in that way. So we can look at this, and give it a once over and say, does it seem like one of these would always be better than the other? Would it be a no-brainer to pick one rather than the other? That's the more generalized definition of this idea of dominance, right? That's always better regardless of what your particular value function looks like. Does one of these guys seem dominant? I would argue no. Because one test that you can use is if one of these options really was dominant, if I just asked you, okay, quick, now that we've done this, which one do you want? It should be really obvious. And if it's not really obvious, then there's probably not a dominant option.